Hey, hi everyone. I'm going to go through the week 7 course notes. Now, today we deal with negatives and deal with negatives on the calculator. But firstly, so negatives, clearly our number line. You can see here's naught. So to the right we go in the world of positive numbers, but to the left we go negatives, and we've avoided negatives till now. But here we go. Now you'll also hear them called directed numbers because we consider the number has both a magnitude, say of 2, and a direction. Could be plus, could be minus. So we're going to consider negatively directed numbers now. Now look at some examples. -3 plus 5. Well, as you see in the example, that's saying start at -3. Well, actually, I should be honest, there's two ways to think about it. You can start at naught, and -3 takes you back 3 spots, and +5 takes you forward 5 spots. We end up at 2. Often that's the analogy I think. When I'm thinking about -3 plus 5, I think I walk 3 steps backwards and I walk 5 steps forwards. Where do I end up? 2 steps forwards. Now, it makes no difference whether you actually walk back the -3 steps or you think I'm already 3 steps backwards. Now I move 5 steps forwards. I end up at 2. Okay? So the step to get from 0 to -3 is quite irrelevant. Either say I walked back 3 steps to get to -3, or I started from -3, same thing. Look at 4 minus 5. In the picture we're saying I started at 4, in other words I'd already gone 4 forwards. If I take 5 off, well, I end up at -1. So 4 minus 5 is -1. The next one here, -2 minus 1. This is the main trap one, because we're coming up to rules soon which talk about 2 minuses making a plus. But that's only sometimes. There's a special set of rules that exist for when to use that. What's -2 minus 1? In the analogy I said before, it's me walking back 2 steps and then walking back 1 step. Where am I? I'm 3 steps back. I'm at -3. The picture shows it too. -2, here I am, -1 is -3. So don't automatically think, oh, 2 minuses is positive. No, that depends. And that depends on, well, this page. So here's the rules that you may have come across before, that 2 pluses make a plus, 2 minuses make a plus. So in other words, 2 of the same signs will give plus, but 2 different signs, plus minus or minus plus, any order, will give a minus. But look at this, they're used only when numbers being multiplied, being divided, or when signs are next to each other. So if I say, what's 2 times -2, I'll say 2 times -2, a plus times a minus is a minus, and 2 is a 4. If I say what's -12 divided by -3, I say, well, numbers are being divided. 12 divided by 3 I know is 4, and a minus divided by minus is a plus, so I'm done. The other, when signs are next to each other, is like the situation 12 plus a -3. Now notice sometimes there's brackets around it, sometimes there's not. I'm basically saying exactly what's here. If there's brackets or not, it's the same question. 12 plus -3, it says when signs are next to each other, it says a plus and a minus become a minus. So both of them become 12 minus 3, which is 9. So if you've got a plus next to a minus, becomes a minus. A plus next to a plus, we know is still plus. A minus next to a minus becomes a plus. So they're fairly simple rules. I've got a bit of a justification here to try and say, well, what's happening? Why does a minus and minus make a plus? So I started out with this statement. This is a 3. -3 is the opposite of 3. What's the opposite of the opposite of 3? So on the number line, here I am. Here I am at 3. The opposite of 3 is here. What's the opposite of the opposite of 3? Well, the opposite of -3 would come back to 3. So those, by saying the opposite of 3 I got here, the opposite of this number is here. So those two opposites took me back where I started. The 2 minuses brought me back to where I began. I went from 3 to -3 to 3. So 2 minuses made a plus. In the next one, I'm trying to do a justification. This is a 3. This is the opposite of 3. Very familiar beginning. What happens when you add these? Well, a 3 added to a -3 gets me back here. 3 steps forward, 3 steps back, gives me 0. So there's proof that 3 added to a -3 gives 3 minus 3, which is 0. So a plus minus makes a minus, minus minus makes a plus. These are examples of exactly what I just did here, and we've already said that a plus next to a minus does indeed become a minus. And this is the example we talked about basically on the previous page. these two numbers are not multiplying, they're not dividing, and those signs are not next to each other. That's just me walking back 2 steps, walking back another step. I've walked back 3 steps. So there's some examples here, and they're examples of exactly what we've just done. A minus times a plus is a minus times a minus is a plus, a minus divided by a plus is a minus. 2 minuses next to each other, brackets or no brackets, makes no difference. 2 minuses make a plus. A minus 2 plus 3 doesn't abide by any of those rules. That's just walking 2 steps back, and then 3 steps forward will land me at 1 step forward. A minus 7 minus minus 1 must be minus 7 plus 1. And if I'm at minus 7, as in if I've gone 7 steps back but I move 1 step forward, I'm only at minus 6 now. A plus times a minus is a minus. A plus times a divide by a minus is a minus. A minus divided by minus is a plus. This plus minus becomes a minus. This minus plus becomes a minus. And 3 steps back plus 2 steps forward, I'm still 1 step back. Now this is a handy little thing. It's not quite so critical when we've got our calculator, but notice if I'm getting asked to do some sort of nasty calculation, like this one gives the example 24 minus 75. It's pretty awkward to walk backwards 75 spots from 24, but if you can see that it's small minus big must give me a negative number, because here's 0, 24 is like here, obviously taking off 75 steps backward is going to get me the negative. The answer will always be negative of whatever the gap is, and it's easier to work out the gap. Big minus small. That's 1, that's 5, so the answer is minus 51. So basically I'm saying whenever you're asked to do small minus big, the answer is always negative. It's easy to just swap the numbers and say, well, what's 20 minus 5? And that's it, the answer is minus 15. So, well, really, it's a very short video today, because that was the intro to say about how to deal with negatives. Now try the examples and that. The rest is about arithmetic on the calculator, and it depends what calculator you have. Now we've got, you'll see there's already a video demonstration that Scott did of the calculator available in the study guides in week 7. I'll also put in another little video that we got paid to make once, just a very quick intro on how to use a scientific calculator. And we did use the FX82AU, be it plus 1 or plus 2 or not the plus versions. They were pretty much the same calculator. And if you have no calculator, I'd definitely recommend getting this type or any natural display when you actually see, like, you've got this fraction key, and so when you write a fraction, on some calculators it'll be like 14 fraction 15 will look like 14, this little L thing and a 15. On a natural display calculator, you actually see it read and write. When you square root it, you see the square root sign. So it's a great calculator. But really it's up to you to get to know how to use it. Just check our guides on the 82AU. And if you do have a different version of calculator and you can't work out how to find the key things, like how do I find to the power of, and on this one it was an x to the power of something. Sometimes you'll just see a button that's a little hat, and you'll just go like 5 to the power of 6 or something like that. But if you've got any issues with it, just get in touch with me, because I think I've seen all types of calculators exist, and we'll sort it out. We'll go into more about the calculator when we specifically do things, but just get to know your calculator, and that's today's vid. Alright, see ya.